Hello friends, so today we'll discuss another question and welcome to my dynamic programming series. This is second lecture, so today we'll see one question and we'll try to solve this problem, and we'll understand the using this problem we'll understand the concept of dynamic programming and how to think recursive solution for this problem. So basically problem is, said you are a traveler on a 2D grid. So you begin in the top left corner and your goal is to travel to the bottom right corner, that is destination, and you may only move down or right. So you have to find number of path, total number of path you can reach to destination. So here like this is one 3 into 3 grid, so you'll start from here, okay, 0 comma 0, and you have to reach 2 comma 2. So how many possible path? So first we'll understand with 2 comma 3 grid, like number of rows is 2, and in this case we can go either from here to here to here to here, one path, another will be here to here, then here, then here, two path, the other will be here, 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 because from here we can move either this way or this way. If we go this way, then from here we have two options, either we can go this way or we can go this way. So here we can visualize same also, like first path, then second path, then third path. So total number of path will be 3. So it's coming 3 only. So like this we have to go. So now if you see 2 comma 2, for 2 comma 2 how many path will be there? Like 2 path only, either we can go this way or we can go this way. So we can see that. So now we have to think about a recursive approach of this problem. So basically for recursive we need some base cases, okay. So every step we have, or recursion means basically we are dividing some bigger problem into a smaller problem. So what we will do, like if you are here, you think if you are here, if you reach here, then there is no need of this grid, because from here you can't go right, you can only go down. So then it will be solution of 2:1 2 into 1 grid, okay. Similarly if you see bigger problem like 3 comma 3 grid, okay. So from here we have two options, either we can go this way or this way. Assume we'll go this, we come to this way, and from there we can either go this way or this way, then there is no need of this row. Then this will be problem of 2 is to 3 grid. So we can divide this problem into simpler sub problem. So what will be the logic? So basically I'm writing one method. You can start your method also. So, and for recursion we need some more thing, like we have to find some base case. So what will be the value if 1:1 comma 1 grid will be there? In that case number of path will be 1 only, because this is source and destination both. So what will be the value if this will be 0 and n will be 1? Then there will be no path, because no grid will be there. Similarly if this will be anything, in that case also if row is 0 means value will be 0 only. Similarly in case of if we take row something, some value, and column will be 0, in that case also there will be no grid. So we find some base case, like if any of this value, either m or n, will be 0, in that case number of path will be 0. In case of m equal to 1, n equal to 1, number of path will be 1. So we got our base case. So we'll start writing recursive method for GridTraveler. So I'm making this method as static, so without creating object we can call from main method. So method will return number of path, that will be integer only, and name will be like I'm taking GridTraveler. Okay, so what will be the argument? It will take row into column, so int mn I'm taking. And what will be the base case? Like if either m equal to 0 or n equal to 0, in that case it will return 0. Okay, if m equal to 1 and if both will be 1, in that case it should return 1. And what will be the recursive function for this? Like from here we understand that if from here we understand that if we move down, in every step we have two options, either we can go right, we can go down. So from here if we start and if we go right, in that case now we have to solve this problem only. If we go right, in that case we have to solve this problem only. So solution for this problem will be this one and this one. So we can think like if we move down, in that case value of row will be decreases. If you go this side, then value of column will be decreases. So in our recursion call we can say that GridTraveler, if we are moving down, in that case will minus m, means number of row. In case of we are moving right, in that case will decrease the number of column. So sum of this will be our solution. So from visualization we are able to see that in case of 2, 3, number of path will be I think 4. So if you run this code, sorry, something is missing. Oh, semicolon is missing. Sorry. 3. So here you can visualize if m is 2 or n is 3, in that case number of path will be 3. That is correct. One this path, one this path, one this path. You can also see that one this, another will be this one, and last will be this one. So there are 3 path. Fine. So problem is like solution is working. In case of 3 into 3, if you run, what will be the solution? 6. It's coming 6. Here also if you want to see, it should come 6. So it's coming 6. Okay, now if you take bigger grid, in that case what should happen? like 18 into 18 grid. If you try this, then solution, it's taking time, because if you see here in visualizer, I don't know it will able to show that 18 into 18 grid or not. I'm not sure. Let me check. It's not, because it will be big only. So here we can, so in case of bigger grid, here also it's not coming. Let's say 5 into 5 grid. I'm checking, I'm not sure it will. So 5 into 5 grid, it's coming. So in case of 5 into 5 grid, size will be, so here, so it's taking so much time and then giving solution. So why it's coming? Now we'll see recursion tree of this one. So if for 2 is to 3 grid, what we are actually doing from here, if we have two options, either we can go down. In case of we are going down, number of row will be one, like one less. If we go right, in case, then number of column will be -1, like this. So if you see this one, so in this case for 2 is to 3 grid, number of sub problems visited is 13. Number of times base case visited is 7. So if you see, you will observe some duplicate problem is also there, like 1,2 we are finding here, 1,2 is also there. So this is like 2 is to 3 grid. If you see some another, like recursion tree of 3 is to 3 grid, it's drawing 3 is to 3 grid here. Let's we check. You know, it's calculating only, like for, if you see for 5 into 5 grid, it's checking all path, it's taking so much time. In this you can see that some of sub duplicate problem is there, like here also we are calculating number of path for 1,2, here also we are calculating 1,2, here also we are calculating. So if we store this one in some place, then no need to recalculate again and again. Here if we calculate 1,2 number of path is here and store somewhere, then when we need this one, we can look up to that map. Okay, similarly for 2,2 also it's repeating, so no need to calculate again and again. So now what we'll do, we'll capture this value in some hash map or something, and whenever need, we'll look up to that map and we'll return value from there. So no need to calculate this again and again. So now we'll go, first I'll see, it's for 5 into 5, 574 cases it have visit, it will take time. So what we'll do, so like previous problem only, we here will pass one hash map. Okay, so what will be the key here, two values there. So I will make some, string as a key and integer as value, integer because number of path will be integer only. I'm making this name as memo. Okay, so here what we'll do, in case of return I'm writing as it is. If m equal to 0, yeah, n equal to 0, in this case what we'll do, we'll put some key into value will be 0 only. So now what will be the key? So basically here there are two variable m comma n. So here I am making one string, that name will be key, and in this I am storing m plus some, this I am taking, you can take different also. So this is our key. So why I'm taking this one, because there are two variables. So row column I want to keep that record. Okay, so generating key using both variable, that's why I'm taking this one. Similarly, in case of this one, we'll put a key and value will be 1, correct? Okay, here instead of returning, here what we'll do, memo dot put will store that value inside key comma value, this will be value, and what will return will return memo dot get that key value. Okay, now first line, what we'll do, if key is already present in that map, will return from here only, like if memo dot contains key sorry, key we have to define first line only, return memo dot get that key. So okay, so this one because I'm using here. So what I'm doing, like if this memo map has already that key, then no need to calculate again and again, will returning from here. If you see here, if 1 comma 2 I'm calculated here, then here I can defer this one, it's already there, so we return that value, no need to calculate again. Okay, so if you now here also we are calling this method, same method, recursion. So here also we have to pass this memo map. Okay, memo map, or from main method also we have to define some hash map string integer, key will be string, and some keeping name same only, equal to new hash map. I'm passing this value in our method. Now if we run, okay, now I have to import that one also now, java.util, because hash map is a class of that java util. Now if we run that code, it's coming. Like if you check for smaller, first we'll check 3 comma 3, we know answer now, 3 comma 3 it should return 6, I think. 6 for 5 comma 5, what should it return? We'll check from that visualizer also. So here if we run, it's coming 70. Here also it's calculating, it will take time. So what we are actually doing, we are checking if value is already there, returning from here, and otherwise we are putting that value into that object. And lastly, here recursion also we are doing, storing here, and in last we are returning memo.getKey. So that's it from today lecture, and if you have any problem you can comment here. So next lecture we'll see some other question, and we'll try to like think how to approach a problem, like how to think recursive way, how to create sub problem from a problem. Like in this case we tried, like if we move this way, then our problem will be smaller and smaller, like that. If you move other, like every step we have two choice. If you go this side, then number of column will be less in your next sub problem. If you go down, in that case number of row will be less, like that. So we can like if we do some question, then we can, if you do some practice and do some like more number of question, then you will be able to think recursive. And for memorization, what we will do, like we'll store that value which we are returning, because if we don't do that, then we have to calculate same value again and again, and then that number of step will be higher, and that time complexity will be also higher. So if you, without like using memoization recursive call, if you do, then you can see here time complexity will be like every step it's 2, then 4, like 2 to the power n time complexity will be there. So if you memorize, then that time complexity will be, I think, less. So we have to calculate that. Okay, thank you from this lecture. If you have any doubt, you can comment.